Hello all. In this lecture, I'll be discussing about deductive proof. So usually we have two ways of proving a statement. One is deductive proof, the other one is inductive proof. So let us see what is deductive proof. So deductive proof, you have a sequence of steps. So first is you will have a hypothesis. So hypothesis is something, it's a theorem which is not proved. Now we have a hypothesis and we need to bring it to a conclusion. So it is of the form of if something, then something. So if hypothesis, then conclusion. So let us consider a theorem. If x is greater than or equal to 4, then 2 power x is greater than or equal to x square. So now you can say that x is greater than or equal to 4. This part you can call it as a hypothesis. Now if hypothesis, then what do we say? This part is called the conclusion. Now, how do we follow deductive proof? First, let us take the hypothesis. So here hypothesis is x is greater than or equal to 4. Now we have to take varying values of x. So here it is given that x's starting value is 4. So let us take a value which doesn't satisfy that condition. So for example, if x is equal to 2. So substituting the value 2 is greater than or equal to 4. So you can say that hypothesis is not proved. So hypothesis is false. This equation is false. So hypothesis is false. Now consider some other value for x. Say the one that satisfy our hypothesis. So take x is equal to 4. So if x is equal to 4, if you substitute x is equal to 4 in this hypothesis, you get 4 greater than or equal to 4, which gives which is proving the hypothesis. So hypothesis is true. If you take a higher value, x is equal to 5, again 5 is greater than or equal to 4. Substituting the value x is equal to 5 in the hypothesis, we say that hypothesis is true. So now h depends on this value of x. So now I can say that hypothesis can be proved for varying values of x greater than or equal to 4. Now take the second part, which is called the conclusion. So conclusion is 2 power x is equal to greater than or equal to x square. Now taking this part, conclusion part, let us give varying values of x. Say let us start with x is equal to 3. So substituting the value 3 in this conclusion, 2 power 3 greater than or equal to 3 power 2. So which gives you 8 greater than or equal to 9, which doesn't satisfy the equation. So which says that conclusion is false. Now according to hypothesis, x is greater than or equal to 4. So we can take values from 4 and above. So next let us substitute x is equal to 4. So when x is equal to 4, 2 power 4 greater than or equal to so 2 power 4 greater than or equal to 4 power 2, which is 16 greater than or equal to 16. Now this equation is satisfying, so the conclusion is true. Let us take x is equal to 5. So if x is equal to 5, substituting the value of x is equal to 5 in this conclusion, 2 power 5 greater than or equal to 5 power 2, which is 32 greater than or equal to 25. So you can see that the conclusion is satisfied. conclusion is true. Take another example. X is equal to 6. So 2 power 6 greater than or equal to 6 power 2, which is 64 greater than or equal to 36. Again, this condition is satisfied. So conclusion is true. So now if you see what is the pattern, we can see that X is increasing by 1 in each of these steps. So as X increases by 1 in each step, we can see that in your conclusion, the left-hand side is doubling. 8 to 16, 16 to 32, 32 to 64, and so on. So left-hand side doubles, right? As X is increased by 1. What happens to the right-hand side? So when you see in the right hand side, you have 9, 16, 25, 36. So the right hand side grows by the formula x plus 1 by x the whole square. Okay, so this is the growth of the right hand side. So now let me explain that. So let us take x is equal to 4. Okay, this value. Okay, so x is equal to 4. Now 4 plus 1 by 4 the whole square, which is 25 by 16. So we are getting 25 by 16. Now you can see that if I multiply 16 with this 25 by 16, you are getting the next value, which is 25. Similarly, take the next x value, which is 5. So 5 plus 1 by 5 the whole square, which is giving you 36 by 25. If you multiply 25 with that value, you are getting the next value, which is 36. Now it keeps on going like this. Now you can say that this is the initial value. X is equal to 4 is the initial value, as our hypothesis is x is greater than or equal to 4. So the starting value is x is equal to 4. Now for x is equal to 4, this is the value that we are getting. And as we move to the next steps, you can see that the value keeps decreasing. So for x is equal to 4, you get 25 by 16 and so on, right? So this is the greater value, which is 1.5625. And after that, in each step, as the x increases, this value keeps decreasing. Okay, so here it is going to be 36 by 25 and so on. So this value keeps decreasing. So we can say that left hand side is doubling, right? So 2 is greater than 1.5625. So your right hand side value cannot be greater than 1.5. As in each and every step, further steps, this value keeps decreasing. So you can say that 2 power x greater than or equal to x square for all values of x greater than or equal to 4. This is true. Hence proved. So this is an example of deductive proof. Thank you.